Okay. Anyway, part 3. No, that makes no sense. In this variant, 5 power modulus calculations are enough to get the final result. I want to account for all the remainders from division along the way. What if I simply calculate the sum of all remainders obtained throughout the process? I wonder if the result will be reasonable. Calculate the sum of all the remainders. So we can't skip forward. So right now what we're doing is we're just skipping to the fifth to the last one. The anti-penultimate. Or whatever it is. I probably said too many antis. Right, so what we're doing is we're jumping forward in time, essentially, to the fifth to the last one, and then just doing those. And now that I look at this, I want to do this, change this back here, say exp. Well, let's make sure the tests are running. Bacon test. Say x minus 5 here, and then just put a min on it. Min 5. Right, whichever is smaller, and that way we don't have to do this nuttiness here. Yeah. And the results are the same. Yeah. Okay. That looks better to me. Because you don't have to mess around with the variables. Git commit -am cleanup. Okay. I'm just delaying right now because I'm trying to think about how do we do this? Because we can't obviously calculate every one. Let's see what we got in terms of the input. We do have these inputs again. So we do have big input to take a look at. Test 3.1 and test 3.2. So we can actually play around with those. I'm going to click download this time because it went from a few lines to 100 lines. What was it called? Okay. And we're just calling it input 3. All right, it's a few more than 100. 998. I'm surprised it's not 1,000, actually. Why wouldn't it be 1,000? Why are 2 missing? I don't know. Okay, I'm not going to worry about that part because now I'm still stalling. What we need to do is sum up all of the remainders. And for this, we could just brute force it, right? Because these are small enough that we can run 3,000 of them. Or 14,000 or whatever. But you can see these numbers here are getting very, very big. What is this? 6.4 billion. And this is even bigger. 86 billion. Almost 87 billion on that one. The mods are small though, which means we're going to have a lot of duplicates. And we know that when we hit a specific number, we're going to have the same sequence of numbers after that. Right? We start with 1. We multiply by n, which is going to be 4, or 6 here, or one of these numbers, right? We mod by 188. So we know even though we're starting with 9716, we're going to end up modding it by 188. So all of the results are going to be in the range 0 to 187. We should be able to use that information to figure out what the final answer will be. Because once we hit a loop, we're going to hit a loop at some point. There's going to be a loop. And then we can just do the loop calculation. So this is something we've done before a bunch of times. And I'm very, very bad at it. I'm very bad at thinking my way through these loops. But maybe if we just do it one step at a time, we'll get it right. We'll call it loop any. And it's going to be the same signature. Right. Let's just put 0 in there for now, and then part 3. is just going to be this. And this will be called loop calculate, which doesn't exist yet, so we're going to have to add that. Right? Okay. Bacon run. Yep. Okay. So right now it's 0. We're going to hit test because we're going to eventually test this thing here. Can we? Yeah. So we have some answers here. So let's do like a basic test loop 1. And we know that this first one here is going to be 132,000, and it's going to be loop loop any, and it's going to be 4, 3,000, and 110. All right. And now we got to figure out how we're going to do this. We're going to start off our score as 1. Right, we still have to do the looping. Or we're still doing the. Oh no, what we're doing is we're adding up. That's right. So let mut sum is equal to 0 because we're just adding up all of the individual ones. Let's brute force it and make sure we get the algorithm right. Because for 3,000, I think we can handle that, and that should be able to test well. And then we can write something cleverer to solve it the right way. So we can say for underscore in 0.exp, right? Score is equal to score times n mod m mod. Answer sum is plus equal to score. And that's all we're doing, and returning a sum. Okay. Very simple. And that test passes, right? But once we get into something bigger, like this is not going to work. So how can we make this smarter? We can look for when we see the same score again. And then we know, what we can do is we can record in the score. So let's create a hash set. Because that's all we need is a hash set. And it's going to contain a pair of view sizes, right? Oh, like that. I forgot the angle brackets, right? So we can say, have we seen this score before, right? Oh, and then what we want to do is, okay, so I think we have to change this here. So let mut step is equal to 0, and then you can say while step is less than exp. And then step plus equals 1. Okay, so now we've done that. Now we can say, is this score something we've seen before? And if so, we can jump forward to the next. So we can say if not visited, insert step and the sum. Right? This says that if insert returns true, that means we were able to insert it for the first time, which means we haven't seen it yet. If it returns false, that means we just replaced it, which we didn't want to do. We don't want to do that. Let's do it this way. If visited contains step sum. Let's do it. Let's just do it this way. That way I'm not messing around with craziness here, right? then what we're going to do is say, we know that, right, we're going to store the steps and then the running total, right, which I'm calling step and sum here. So let next steps is equal to steps. Oh, let's get it. If let sum prev step prev sum is equal to visited get. Okay, I'm going to map. Just a map. We have to map this. I've got this backwards here. We're mapping a score to the sum. That's what we need to do. Okay, I think I'm getting there. Right. So this is going to be, let's say, step minus the prev step. Let's call it delta steps. And then delta sum is equal to the current sum minus the prev sum, right? Now the amount we're going to go is going to be equal to the distance we have left. So it's going to be is equal to the exp minus our current step, all divided by the delta, the steps we did, right? And now we can increment our sum by our delta sum times the amount that we took to get there, and then we can actually modify our steps also by the delta steps times the amount. If this works, I'm going to be amazed. Right, and then we just return our total sum. Oh, hash map is not imported. That means we can also get rid of hash set. Variable does not. Oh, did I forget to? I did. Okay, so after we figured these things out, or if we haven't visited before, either way, we're going to insert into visited, right? So we're going to say visited insert score, and we're going to do step and sum. I think that'll work. That seems to work for the simple case. Where is it? Loop 1 here. Let's make sure it works for the complicated case. Now this is a full-on test. Let's do a couple more of these just to make sure. I can stick these in here, right? Let's do 3 more. Let's do this guy here, 55.99.40, and that was 4 and 14,000 and 120. Oops. Let's do this one, 12 with 5 there, and that's a 9, 16,000 and 150, and then finally, sure, this last one here. That guy there, this is 8, 16,000 and 160. Those tests all pass. I'm looking over here. I didn't see any errors come out there, so that's how I knew they passed. Let's do this. Let's paste this in here. Cat grid and test 3 to text. Right, and then see if that test works. That works, and I think we're golden. Test part 3. And it's basically this with everything changed. Oops, I hate when I do that. So we still do that, and we do this, and this is going to be the new number here. Copied, okay. I don't like the fact that it copies it with spaces in there. And instead of trunk calculate, it's going to be loop calculate. Hey, what do you know? It worked. Okay, so I think we're ready. If I hit run over here, no, it failed. Oh no, it came up with an answer. It just took longer than I thought it would. Let's see if it's even vaguely close to being correct. I've cracked the code. That's the right answer. So I'm in global place 55 with a global score of 96. All right, and it took me 52 minutes to solve the whole thing.